Okay, so let's do this. How do I get, first of all, let's do the POH. What's the POH?
POH is 9.6.
Yeah, the POH is going to be simply what? POH is going to be equal to the what?
14 minus pH.
14 minus pH, right? So we have the 4.4 is the pH, the POH is going to be, what is it? 9.6. Okay, good. And how do you get the hydronium ion concentration from the pH? How do you do that?
Put the negative on the one side and then 10 to the power of that number. 10 to the
Yeah, in
power.
other words, if you raise both sides of the equation to what? Raise both sides of the equation to what? Right, so I want to raise that to what? What do I want to raise that to? Ten to the x, what am I going to substitute in for x?
Negative pH.
The negative pH. So 10 to the, what's the negative pH? Negative 4.4. So what's 10 to the negative 4.4?
3.9.
Does everybody get it? Do you know how to put that in? 10 to the negative 4.4. What does it equal? 10 to the negative 4.4 equals what?
0.0.
I need it. Don't give it to me. Give it to me in scientific notation. We don't do.
3.98.
So 4.
Yes.
3.984 times 10 to the
Negative.
negative what? Negative fifth? Is that right? So it's an ion concentration and it's in molarity, so you put it in brackets. Yes? What's the hydroxide concentration? What's the hydroxide concentration? Don't you do the same thing? What's 10 to the negative 9.6? What is it?
2.5 times 10 to the negative.
2.5?
Yes, 2.5 times 10 to the negative.
Jen, what'd you get?
2.5 times 10 to the negative 10.
Times 10 to the negative 10. That's right.
Never said anything else.
Yeah, Kamal, I was wondering what you were saying to me. You just said 2.5.
I said 2.5 times 10 to the negative 10.
I didn't hear the rest of it. Okay, cool. All right, any questions on that? Now, let me ask you this. Are you ready? All right. Multiply the hydroxide and hydronium concentrations. Multiply them. While you're doing that, Nabil, I need here, come up here, please. I need you to get that thing back. I'm going to read. I said that we would research where the hydronium concentration came from. Stand over there. Just get that for me. I'm going to read something. We have an answer. Okay, God bless Britannia. Okay, the Britannica Encyclopedia. It says, are you ready? It says, Arrhenius theory introduced in 1887 by the Swedish scientist Svante Arrhenius, that acids are substances that dissociate in water to yield electrically charged atoms or molecules called ions, one of which is the hydrogen ion, H+, and that bases ionize in water to yield the hydroxide ion. It is also known that hydrogen ions cannot exist alone in water solution. Rather, it exists in a combined state with the water molecule as the hydronium ion. In practice, the hydronium ion is still customarily referred to as the hydronium ion, so we have Arrhenius to thank for that. Well done there in the bill. God bless all Ethiopians. Excellent, well done. Okay, excellent. Yes, now, what is the product of the hydroxide and hydronium concentrations equal to, Jen?
1 times 10 to the negative 14.
1 times 10 to the negative 14th. Excellent. Excellent. And that's another way to get one with another. In other words, what equation can we now say exists? What's 1 times 10 to the negative 14th? Anybody in their reading come across that? I know that you're all recovering from massive brain trauma and that you're still, like, relearning everything that you knew. But is anybody here today? Anybody? Shout if you're here. That was really loud. Yes.
I'm here.
All right. Kamal's here. Excellent. Mr. Nair's here. He's like stunned. I call this very affectionately my zombie class. These are my zombies. Yes, of course. Yes.
Okay, I think.
He thinks.
I think that 14 has something to do with pH.
Correct. Very good.
And it's the number that I was arguing with you about incorrectly
Yes.
days ago, and I said it equals 1.
Correct.
And what I left out was the pH times the PO, and that's right. It's KB times KA equals 1 times 10 to the negative 14.
No, what it would be would be the hydronium concentration times the hydroxide concentration.
What did I say?
You said the Ka times
Those
Kb.
are KA and KB.
Right, no, it's the concentrations is going to equal
1 times.
Kw.
And KW equals 1 times 10 to the negative 14.
Correct.
Write that down so I can take a picture of that, because I got
Okay.
work to do.
All right.
So you guys even though I have to say.
All right. So, end of part 2. Are you okay with that? Yes? Okay. Kw is 1 times 10 to the negative 14th. That's all it is. Understood? And it should make sense, because what is the negative law of 1 times 10 to the negative 14th? What is it? It's 14. Right? What is the log anyway? What is that? What is the log? It's really the exponent. Aren't we talking about the exponent, right? Yes? Yeah, but they don't really study logs like we studied it, where you have to look up tables and you have the mantissa. And... All right, end of part 2. Okay.
What are you guys doing next?